In chapter 17, we're going to work with rational expressions. The first thing we want to do is find out when a fraction is undefined. Think about this. A fraction is undefined if the denominator equals 0. For example, 18 divided by 0 does not exist, is undefined. Therefore, we want to find where the denominator is 0 in this algebraic fraction. So look at the fraction. Don't worry about the numerator. Look at the denominator, v squared minus v minus 6. Set it equal to 0. Factor it. It looks like a simple trinomial with a coefficient 1. I think the factors are v minus 3 times v plus 2. Let's check that out. V times v is v squared. The inside product is minus 3v. The outside product is 2v, which gives me a total of negative v. And the last term is multiplied as minus 6. If a product is equal to 0, the conclusion is that one of the factors must represent 0. So set v minus 3 equal to 0 and solve. V equals 3. Set the factor v plus 2 equal to 0 and solve. V is equal to minus 2. Therefore, this fraction becomes undefined when either v equals 3 or v equals minus 2. In this problem, we have an algebraic fraction. We like to reduce it. You cannot cancel until we have products. So we always must factor the numerator and denominator first. And then we're going to cancel like factors. The numerator has a common factor of 6, 6 parentheses t minus 4. The denominator is the difference of two squares, therefore t plus 4 times t minus 4. Notice we have like factors. The quantity t minus 4 cancels in the top and bottom, and that leaves us with a fraction of 6 over t plus 4. Here is another fraction we would like to reduce or simplify. Either word is okay. They mean the same thing. In the numerator, we see a common factor of a. So we're left with a squared plus 13a plus 40. If we go down to the next step, this step, we want to factor the denominator. I see it as a trinomial with the leading coefficient is 1. So factors of a squared are a and a. Factors of 50 are 25 and 2, 10 and 5, 15 and 1. Which of those combinations would either add or subtract to give the middle coefficient of 5? I think 10 and 5. What about the signs? If the inside product is negative 10a, and the outside product is plus 5a, the difference is minus 5a. The negative sign has to go with the larger number. Lastly is the product of the last terms minus 50. Yes. We need to continue to factor the numerator now. Again, I do the same thing. A squared factors into a and a. Factors of 40 are many, but the combination is going to give me 13, would be 5 and 8. What sign do I choose so that I get a total of 13a? How about 5a and 8a would add to be 13a if they're both positive. Now that we've factored both the numerator and denominator completely, we see a pair of like factors, a plus 5, so they cancel, and are left with the answer in factored form of a times a plus 8 over a minus 10. Let's look at this problem in terms of reducing, and we want to note the result. Note that the binomials, the numerator and denominator, are exactly opposite. Plus 1, negative 1, minus y, plus y. They're exactly opposite. Let's factor minus 1 from the numerator. If we factor it out, we're left with minus 1 plus y. And if we come down here, all I did is rearrange the order of these two terms to put the plus y first and the minus y second. Notice also In the original problem, there's no parentheses in the denominator, but to emphasize factored form, I put parentheses around it. Because what we're doing is canceling like factors, not term, but term. That's illegal. But the quantity y minus 1 with the quantity y minus 1, they both cancel. I'm left with a minus 1. So if we see expressions, a numerator factor and a denominator factor that are exactly opposite, we can cancel, and what we leave behind is a minus 1. We don't have to go through all this work. If they're opposite, we just cancel and leave a minus 1.